Welcome to my ENME351 Lab 9 project. I created a password-protected automatic door unlocker. It starts with an ultrasonic sensor, and when an object is within 5 inches, it displays "Welcome, enter password." This LCD is controlled by a potentiometer that changes its resolution. We then have an IR remote and an IR receiver. When you enter a password, if it is incorrect, it will display "wrong password" and nothing will happen. If we enter the correct password, the stepper motor will start to turn and it displays "correct password." When the correct password is entered, this cable on the first Arduino is written to high, and this cable on the second Arduino is entered to read this value. We have a pull down resistor in the middle so that this value is not floating. After that, it sends the stepper motor to run for 3 seconds, and later this will be connected to a rubber band and around the lock on a door.
So here's my code for the first Arduino. We start by calling two libraries, the IR remote and the LCD. We define the button values from the IR remote. We set our password as 9462, and we set an attempt array as 4, and then the index for placing the values into that array. We initialize the LCD screen, and then for the ultrasonic sensor, we set the trigger as 6 and echo as 7. Here's a reference to parallax for converting microseconds to inches based on the speed of light. This loop prevents both displays from running at once. We set up the serial monitor, we set up the IR receiver, and we set the LCD screen with 16 elements in each row and two columns. We set the trigger as an output, echo as an input. We write the trigger low, then high, and then we measure it using the pulse in command. And then we convert that microseconds to inches from the pulse in. So then we set an if statement for the ultrasonic sensor saying that if the object is within 5 inches and that the loop's not running, so like the welcome screen's not on, we print the welcome screen. Or if the password screen isn't on, we set the welcome screen. Then we have all our cases for the buttons. Essentially, whichever button is pressed, it'll print that value to the serial monitor and then enter the value into the attempt array. So then we check if the attempt is correct by using a bool value, which is the success, which is equal to true. So if the attempt is not equal to the password, success equals false. And then we print that the access was denied and print the wrong password on the screen. And then if the success is correct, the access is granted. We write pin 10 to high, which connects to the other Arduino. And then we delay for 3 seconds, set pin 10 back to low, and then print the correct password on the LCD screen. And then down here, we just reset both the array index to 0 and the values inside the array to 0. And then this prevents an infinite loop from the receiver. So after pin 10 is set to high, this Arduino code checks right here saying, if that pin is high, we're going to move the stepper motor for those 3 seconds. So here's the processing code. It's similar to the Arduino where we define the strings and then we set an attempt index. Here's a couple Boolean values: access result false, result displayed false. These are checks to see if we should display the result and if we should access the result. We draw the squares, we check to see if the attempt has been entered, and then we print it in the squares. Here's the checks to see if it's correct. If it's correct, we're going to print correct with a green background. If it's incorrect, we print incorrect with a red background. And then here's the serial data that's coming in, and it's a backup plan to see if access granted was printed to the serial monitor of the Arduino or if access denied was. And if that happens, we go back up and do this again. And then here is to reset it down here. So I'll put in the correct password now. And as you can see, it will turn green. And then here's if I put in the wrong password, 0, 0, 0, it will go red.